Algebra 2 Honors, Lesson 11.2, Arithmetic Series. So a lot of people go, whoa, we just did this. And that's the big question. What's the difference between a sequence and a series? Well, this is a sequence. You go 3, 6, 9. Oh, that's going to go 12, 15, so on and so on. The common difference is 3. A1 equals 3, so on and so on. Well, a series means add them. We will do geometric series later where we multiply to get from term to term, but the series still means to add them. That gets a little confusing, but don't worry about it. So we want to add them up. Find the first 6 terms and add them up. 3 plus 6 plus 9 plus 12 plus 15 plus 18. Usually at this point, people just start adding them. But I point something out that if you can add the first 2, you get first and last one, you get 21. If you can add the 6 and the 15, you get 21. And the 9 and 12 get 21. You end up with 3 21s, which is just 63. Simple enough. Well, that's how we actually add up arithmetic series. We take the number, divide by 2. That's this piece right here. There were 6 terms. Divided by 2 is 3. Take the first and the last term, add them together, and boom, we're done. Another way to write this is by subbing in A1 stays. AN is A1 plus D times N minus 1. So we could write this as N over 2 times 2A1 plus D times N minus 1. Not really a big deal, just something else to think about. So, find the sum of the first 100 positive integers. 100 over 2, 1 plus 100, 50 times 101, 5,050. Now, you might think I was going to do the other way, which I guess I will, but I always show Gauss's way. Don't write this down. I'm going to erase it. Well, actually, I'll put it down here. Gauss just pointed all this out. 1 plus 100 is 101, and then he realized there's 50 pairs times 50, and that's what we just did. So the other way is 100 integers divided by 2. 2 times 1, that's the A1 value, plus the difference, 1 times 100 minus 1. You're probably thinking, why would anybody ever do it this way? I say, you never know. 2 plus 99. 50 times 101. Again, 5,050. But just 2 different ways to do it. Let's go backwards. Find the first 3 terms of an arithmetic series with A1 equals 9, AN equals 105, SN equals 741. 741 equals N over 2, 9 plus 105. Add them. Divide by 2, we get 57. N equals exactly 13. Nice part of the problem is if you screwed up, you wouldn't get an exact integer. You'd get some decimal. Then you better go back and check your work or come and talk to me because I probably screwed up the problem. You're saving money each month, and you can't say, I can put $10 more away each month. I'm disciplined, I'll make it happen. So you're looking at 10 plus 20 plus 30 plus 360. How much money do you put away? Want to add it up? 36 months, 36 over 2, 10 plus 360 equals $6,660. So I mean, I hope I don't sound incorrect here, but I mean, this is not that complicated stuff. Just plug it and chug it. Something a little different. What the heck is this? It's called sigma notation. That is a capital sigma. It means sum up. I'll actually write it as add up. How do we sum up? Well, we know there are 10 values, and be careful because I'll make tricky questions like the one directly below. We put in 1, the first term, sum of the 10 values is 10 over 2. Put in 1, we get 3 times 1 plus 3 times 10. Is another one if you, unless there's decimals in the arithmetic series, you really should get a integer answer. But you never know. Could be going up and down by 0.4, so you never know. So this one's a little trickier. Add them up. We got 5, 6, 7, 8. That's kind of a hassle. I don't like to do that. Let's find what n equals 5. 3 times 5 minus 4 is 15 minus 4. It's 11. N equals 8. 3 times 8, 24 minus 4, 20. 5, 6, 7, 8. N equals 4. You can do this any way you want. You can relabel this as 1 and this is 2. It does not matter. As long as you keep it consistent, the sum, I'm going to put 5 to 8 equals 4 over 2. First term, 11. Last term, 20. The sum of 5 to 8 equals 62. Interesting stuff. Let me just look at this as an arithmetic sequence. It would go 11, then go up by 3, 14, go up by 3, 17, go up by 3, 20, 5, 6, 7, 8. So I just like to make sure everything makes sense. I have a tendency to make mistakes. How about going backwards? Can you write the problem at the top of this page in sigma notation? That means this one, the 10, 20 up to 36 months. Doesn't matter what variable you use. N equals 1 to 36. First month is 10, then 20, then 30, Can we just go with n times 10? 10, 2 times 10, 20. There it is. So that's writing it in sigma notation. And I feel really weird about leaving it as n.10, so I'm going to call it as 10n. Parentheses, no parentheses, doesn't really matter. All right? The last one would be 360, and then you can just do the math, add it up. Hope that makes sense. Happy mathing.